still working on reading? What are you up to? Okay, so you put it in the journal? Okay, next is, yeah. Well, writing should have been done already, so we're 45 minutes behind, okay? So writing, go back to the same assignment from yesterday, and just go to the writing, writing, no, go to the writing classroom, Google Classroom. So read this. What is this? Also, you can really use in your own thing. Now, don't do it in here. Do it in your class. I want to do it. Okay?
Okay, let's begin. So today we talk about binomial probability. So before getting into that section, we want to briefly review factorial and permutation and combination first. Okay, so you may see this example I provided already. So look at the one example here. So 8 people compete in a downhill ski race, assuming that there are no ties. In how many different order can the skier finish? So in this case, we have total 8 different spots, right? And then we need to understand, we don't have any information of each player, so they have equal chance to be first place or the last place here. Okay, then think about how many people can be the first place. So if you think 8, that is correct, because all 8 people have equal chance to be first place, so there are 8 possible choices here. And now after we choose one player here, then second place will be only 7 players, right? And next then 6, 5, 4, 3, 2, 1, like that. So end of the last person, there's only one person left here. So like that, the whatever number of people compete or number of people we organize something, then it become, we multiply total number of case, and then you multiply one reduced number here. That is called factorial. The symbol is like this. So if you using the calculator and then type 8 factorial, then you will get the answer. Okay, so usually most of the calculator, it shows that you took a PRB button here, and then 8 PRB and choose factorial, then you will get the answer. Okay, what's the answer for this problem? So let's see. So 8 factorial. So that's to be 40,320 different ways. Okay. Now, then, what if we only determine? So here the same question, but I'm gonna switch a little bit. See different order to then determine the first, second, and only third player, which means we are determining only 3 winners. Okay, then this case, out of 8 different people before, we only setting 3 digits. So it can be first and second and third digit here. So of course there are 8 people can be the first place. Hopefully you get it. Y is 8 again. But now second become 7, and then third become 6 here, right? And then from the fourth digit we don't care, because we only want to determine first, second, third digit only. So this case, the probability formula we always call permutation. So you can write 8 P 3 like that. Okay, so let's check AP3 on your calculator. So 8 P, oops, so 8 P3, then this become 336 ways here. So do you see the difference between A factorial and then the permutation AP3? So like the major difference between the permutation and the factorial. So factorial case, we are finding total number of cases here. So from the beginning to the end. Now permutation, you can limit some digits. Okay, so it's kind of same concept of the factorial, but permutation always limited digit. Okay, so anyway, so that's why, so this answer become 336 different cases. Okay, then now here, so based on these 2 information, let's talk about the pizza store here. Pizza shop offers 12 toppings. No topping is used more than once. What is the probability that you choose pepperoni, onion, and mushrooms? Okay, so this case, now out of 12 different toppings. Okay, so based on what we have learned, if we apply that, then this is going to be 12 factorial as the total cases. We choose from the total number to end. But here we only choose how many? 3 toppings. So far we can set up 12 P 3 here, right? Okay, then which means if you calculate 12 P3, then it's coming out 13, 20 different ways we can find out. Okay, however, let's think a little bit more carefully here. So in this case, if you choose pepperoni, onion, mushroom, or pepperoni, mushroom, onion, or onion, mushroom, pepperoni, or onion, pepperoni, mushroom, and mushroom, onion, pepperoni, or mushroom, pepperoni, onion, and they all same type of pizza? Yes, they are. So they are exactly same type of pizza here. Okay, so of course this is a little bit out of the track here, but the reason I determined the 3 different toppings so that I can generate more detailed information. Okay, so since these 6 different cases are exactly same type of pizza, so you can make this is the 12p 3 over basically 3 factorial again, because that represent, those are all the same kind of pitches here. Okay, so then now permutation case, how did we do that before? So we did 12 times 11 times 10 here, and then this one become 3 times 2 times 1, like that. Okay, so this formula we just call combination. So if we set up as a formula, then this become, so NCR, this equal to basically NPR over R factorial. Another word you can do, so NCR equal to N factorial over N minus R factorial times R factorial, basically. Okay. Okay. So now, so we know that if we don't have to worry about the order, then we can use combination instead. Okay. Then now we are getting into binomial distribution. Okay. So the binomial distribution, so the binomial experiment. A binomial experiment is a probability experiment that satisfies the following condition here. A, the experiment is repeated for a fixed number of trials where each trial is independent of the other trials. B, there are only two possible outcomes of interest for each trial, and the outcomes can be classified as a success or a failure. And C, the probability of a success PS is the same for each trial. D, the random variable X counts the number of successful trials. Okay, so let me, because the people cannot see the whole screen, so I'm gonna adjust the screen size here. So let's see, now you can see that. Okay, I guess now you can see. So I'm gonna limit the space, this range here, so there's no problem to see the whole screen. Okay, now N represents the number of time a trial is repeated. P equal to PS, the probability of success in a single trial. Q, that's PF equal to the probability of failure in a single trial, or Q equal to 1 minus P. And X, the random variable represent a countable number of success in N trial. So it can be X equal to N, 1, 2, 3 until N basically. Okay. So binomial probability formula here. So Px equal to NCx and P to the x and Q to the n minus x, that equal to n factorial over n minus x factorial times x factorial, and Px and Q to the n minus x. Okay. So we want to explore why we set up this way, a little bit more detail. Okay. So I'm gonna use this example and then maybe explore more details. So let me make a little bit bigger so you can see better. Okay. So you are taking a multiple choice quiz that consists of 5 questions. Each question has 4 possible answers, only one of which is correct. To complete the quiz, you randomly guess the answer to each question. So find the probability of guessing A. exactly 3 answers correctly, B. at least 3 answers correctly, and C. less than 3 answers correctly. Okay. So what's the key point here? So there are total 5 different questions, right? So I can make maybe number 1, number 2, and number 3, and number 4, and number 5. And each question has 4 possible answers. It means we can make A, B, C, D. Of course, like this, right? Like that. Okay, so out of these choices, only one of them is the correct answer, basically. So, as you see, in this case, I don't know the correct answer either, so I'm gonna just choose. I'm gonna say C is correct answer, and A is correct answer, B, D, A, something like that. Okay, then for each questions, we can determine probability correct, C represent correct, then there will be 1/4 basically, right? At the same time, probability incorrect, there will be 3/4 because of this 1 question correct and 3 questions would be incorrect. So that's the reason we can set up probability correct become 1/4. Probability incorrect becomes 3/4 here. So we want to find out exactly 3 answers correctly. Okay, so out of these 5 questions, we are finding 3 questions correctly. Okay, so now, so let's say if you choose number 1 C, then it is correct. But you know that there will be 1/4 probability. Now, second questions, you choose A, then there also 1/4 probability. Third case, you choose B, then there's also 1/4 probability here. Then because we set up 3 answers are correct, others will be incorrect. 3/4 and 3/4. So in this case, we can rewrite this 1/4 to the cubic, and then 3/4 to the second power here. So this exponent represent, this one is number of success, and this is counterpart, in this case number of failure. Make sense? But this time we only talk about one case, one scenario. Correct, 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 incorrect, incorrect here. But as you know, we don't have to always choose 3 questions correctly. We can make maybe the first question correct, second is correct, but third is incorrect, fourth is correct, then last one incorrect. They also represent 3 questions correctly. So even though your first question is incorrect, but second is correct, third is correct, fourth is correct, fifth is incorrect, also represent 3 questions correctly. So in this case, there's no order, doesn't matter. We only find out 3 answers correctly. So is it permutation or combination? Yeah, if you think combination, that is correct. Now, permutation, we always care the order. Now, the combination, we don't care the order. So we need to find out total ways to find 3 questions correctly out of 5 questions. So there will be 5, C, 3 first. Okay. So if you do 5, C, 3, then you will get 10 different ways. There will be 10 times. Now each case we have correct case 3 power, incorrect case second power here. Make sense? Yeah. So that's why if I just write as a formula, it becomes 5C3 1/4 third power and 3/4 second power. In other words, we are finding 3 success trial and then others failure trial here. Okay, so just calculate that. So if you do it, so 1/4 to the, so 10 times 1/4 to the third power times 3/4 this square power. Then you will get the 0.08789, so we can round 0.088. Okay. Okay, then now, so let's look at the second question here. At least 3 answers correctly. So at least 3 questions correctly. So we need to understand what does at least means. You should at least 3. Is it 3 or more, or 3 or less? So I'm gonna give you 2 choices. Does it mean 3 or more, 3 or fewer? So think about that for a second. If you choose 3 or more, that is correct. Please understand, least means smallest number. So at least 3 means 3 or more, not 3 or fewer. If you want to make a 3 or fewer, then it should be at most 3. Okay, so clearly this one is same as at most 3 basically. Okay, so please be careful. Okay, now then we are finding out at least 3. So then which means 3 correct and the 4 correct and the 5 correct, right? Make sense here? Okay, then this case you can find out probability 3 correct, probability 4 correct, probability 5 correct. Unfortunately, we cannot find the probability at least 3 at once. So you have to do case by case. So and then combine them all later. Okay? So this case, we know this answer already because we found out exactly 3 answer, which is 0.088. Now P4, which means there are 4 questions correctly. Therefore, we can set up we can set up 5C4. So you know, if I write 5C4, now you know we are finding total number of ways we set up 4 questions correctly. Order is not mattered, so is going to be 5C4, not 5P4. And then we are doing 1 4 to the 4th power. Why? Because you need to multiply 1/4 4 different times. So that's why it's going to be 1 over 4 to the 4th power and 3 over 4 to the. Now, if out of 5 questions, 4 questions correct, then how many are incorrect? Yes, exactly. 1 is incorrect. So simply you can do 5 minus 4, then there will be 1 here. Okay? If you calculate that, so 5 C4 1 over 4 to the 4th power 3 over 4 to the single power, then you will get 0.01464, something like that. So we round 0.015. Okay. Yes.
We cannot see the screen. You have to move down a little bit.
Move down a little bit. Okay. Okay, now next one is all 5 are correct. So then this is going to be, so 5 C5, and then as you know, we are finding all 5 questions correct. And this become okay. So we have a little bit technical problem. So we are going back to live lesson really shortly, right after fixing this problem. doesn't get back. Can you see now? So okay, I'm trying to fixing this problem. So I'm getting back. Okay, so because someone asked me one question, so I'm gonna answer the first. Okay, so someone asked me probability 3, so I'm gonna explain one more time and then go over to other questions. Okay, so P3, there are 5 total questions, so you can do N, C, 5, C, 3 here. Okay, thanks for waiting. So now I'm doing it again. So P3. So someone asked me, how can you set up P3? That will be 5 C3, that equal to basically 5 factorial over 5 minus 3 factorial times 3 factorial. So if you don't have the scientific calculator, you can do it this way, or when you do that, you have any scientific calculator such as TI-30 series or Casio, then you can do type 5 first, and you will see PRB button. Click that, and then find out NCR. Then you can find out NCR here, and then type 3. Then that's how you calculate 5 NCR. Okay, then you can find the 5C3 basically. Okay, and then so because technical problem I lost the last file, so I'm gonna do it again from the A here. So P3 means 5C3 104 third power 304 second power. So it means the three question correctly and two question incorrectly, then you're supposed to get 0.088. We found it. Now B, we are working on B, and the probability at least 3 correct. So now we found out that, which means 3 correct, 4 correct, and 5 correct, and you need to find all separately. Okay, so we know P3 already, which is 0.088. Now P4, there will be 5C4 1 4 to the fourth power, and then 3 4 to the single power. So another way, it means you're finding total number of cases that 4 questions correctly with order doesn't matter, and 1 4 to the fourth power represent 4 questions correctly, and then 3 4 become 1 question correctly. Okay, so if I do 5C4, so 5C4 and the 1/4 to the fourth power, 3/4 to the single power, then you will get 0.014648 like that. So we can round 0.0146. Okay, now P5, which means they're all correct, right? That's why I'm writing 5C5. Then you can make 1/4 to the fifth power and 3/4 to the 0 power basically. So if you calculate that, there will be about 0.000976, so like around 0.001 basically. Okay, because I'm rounding up, try to 3 decimal digit. That's what I got this way. Therefore, now we can make, so probability at least 3 means probability 3 plus probability 4 plus probability 5, which is 0.088 plus 0.0146 plus 0.001. The answer becomes about 0.1036. Okay, so that will be the answer for this problem. Now moving on C. So C is less than 3 answers correctly. So less than 3 answer correct, which means it can be nothing correct, or 1 correct, or 2 correct. So you need to find out P0 and P1 and P2 in this case. Okay, so as we did already, so you can set up 5 C0 1 fault 0, now 3 4 to the 5th. So you know why I set up this way, right? Because now as you see nothing correct, then 5 must be incorrect. That's what this means. So you calculate that. You got 0.237, and now 1 means 5C1, which is 1 4 to the 1, only 1 correct, and then there are 4 incorrect. You can make like this one. Then you will get 0.3955, so I can round 0.396. So that's the 1 question correct, and 2 correct. So 5C2 1 4 to the 2nd power and 3 4 to the 3rd power. If 2 correct and 3 incorrect, there will be total possible way to determine only 2 is correct without order matter. So 5C2 1 over 4 to the square power, 3 over 4 to the 3rd power, then it come out 0.2636, so I can make 0.264. Okay, so therefore, so probability less than 3, which means we are combining P0 plus P1 plus P2 here, which is 0.237 plus 0.396 plus 0.264. So then the answer come out 0.8974, this problem. But now just want to make sure another way here. So because we have total n equal to 5, which means we can make nothing correct, 1 correct, 2 correct, 3 correct, and 4 correct, 5 correct, then must be equal to 1, right? Now from the previous questions, because we have the questions at least 3, which is 0.1036 already, it means, you know, this probability we have 0.1036 already. Okay, then the last question we asked less than 3 that represent P0, P1, P2. Of course, this is such a fewer number of cases, so I just did it. But if you know, this means, you know, counter probability of this probability, then you simply subtract 0.1036 from the 1, then you can find the answer basically. Okay, so P0 plus P1 plus P2 and will be 1 minus 0.1036. If you do it, then you will get 0.8964, approximately 0.897. So we got exactly the same answer that we did here as well. Okay, so sometimes, so of course, it will be always correct. You just find out all individual probability and combine them. But on the other hand, you better think about counterpart probability, then your calculation may be much easier. Okay, so then let's look at one more questions. Okay, so here 59% of men consider themselves professional baseball fans. You randomly select 10 men and ask each if he considers himself a professional baseball fan. So find the probability that the number of who consider themselves baseball fan is A, exactly 8, B, at least 8, C, less than 8. Okay. So now, do you see difference between the first example and second example? Yeah, the first example, we asked and we set up just 4 possible answers, which means you have to find out the probability for target value here. But this time, we give you the probability value already, which is 59%. Okay. Sorry. So if 59% of men they are baseball fan, then counter probability, which is 41%, they are not baseball fan. We can do like this, right? Okay. So from here we can set up P equal to 0.59 represent baseball fan, and then Q must be 0.41 represent not a baseball fan. Okay, And then you randomly select 10 men, which means n equal to 10. And now we can solve this problem basically. Okay, so sorry, A, exactly 8. So 8 people say, oh, I'm a fan of the baseball. Okay, then we can find out probability 8. So here 10 out of 8 people say, yes, I'm a fan of the baseball, right? Then you can set up 10 C8. In this case also order doesn't matter, because you randomly select 8 people. You know, it can be first 8 people, but it doesn't have to be first 8 people. That's why we set up 10 C8. And then what's the probability people answer baseball fan? Yes, 0.59. So 0.59 to the 8th power, and then 0.41 to the 2nd power here. If 8 people say yes I am, then 2 people say no I'm not, right? Yeah, that's the reason I set up P8 equal to 10C8 and 0.59 to the 8th power and 0.41 to the 2nd power. So let's calculate that. So 0.59 to the 8th power, 0.41 to the square power. Then you will get the answer 0.11106. So I can round 0.1111. Okay. So now B at least 8. Okay, so we are doing at least 8 people. So at least came out again. So at least means 8 become the minimum. So we find the probability 8 people say yes, or 9 people say yes, or 10 people say yes. So we are finding 8 people say yes, 9 people say yes, and 10 people say yes. So you need to find 3 different probability here. Okay. So now we know probability A already, which is 0.1111. Now we are looking for P9, which means 9 people say yes, right? So 10 C9 and 0.59 to the 9th power and 0.41 to the 6th power. Don't forget that, you know, if 59% people say yes, then other percentage, you know, some of the percentage become 100%. So 0.41, there must be not a fan probability, and the sum become 100%. That's why I got 0.41 as well. So 9 people say yes, so become 0.59 to the 9th power and 0.41 to the single power. I hope this is clear. Okay. So we also have to find out P10, which is 10 C10, 0.59 to the 10 power and 0.41 to the 0 power. Yeah, of course, right? If 10 people say, all 10 people say yes, then nobody say no. That's why it becomes 0.41 to the 0 power. Okay. So we can do just calculate 10 P9 and P10. So 10 C9 0.59 to the 9th power, 0.41 to the single power. Then you will get 0.03351. So I can just stop as 0.0335 and 10 C10 times 0.59 to the 10th power times 0.41 to the 0 power, and this becomes 0.00051. Okay, so we found all each probability, so therefore we can set up probability at least A correct, which means P8 plus P9 plus P10, which is 0.1111 plus 0.0355 plus 0.00051. So 0.1111 plus 0.0355 plus 0.00051, that equal to 0.14711. So we can make 0.1471. That will be the answer for this problem. Okay, then go back. Continue the letter C. So less than 8. So probability less than 8 people. Okay, less than 8 people, which means nobody say yes, or one person say yes, 2 people, 3 people, 4 people, and 5 people, and 6 and 7 people say yes. Okay, so technically you need to calculate all P0, P1, P2, P3, P5, P6 and P7 all separately, and you combine them. Then you will get the probability less than A here. But as you see, it's too many different cases. For the last problem, we also maybe watch out the counterpart probability. In this case, I can make P0 plus P1 plus P2 plus P3 plus P5 plus P6 plus P7 plus P8 plus P9 plus P10 equal to 1. So it is always through the sum of all different cases of the probability, their sum must be equal to 1. Okay, now so far we have this probability because through the question A and B we found at least a probability which was 0.1471, right? Okay, now finding from P0, P02, P7, all these cases is the same as you eliminate this amount from total 1, isn't it? So therefore, instead of finding all these cases, I'm going to subtract this value from the 1. So I can rewrite that. So P0 plus P1 plus P2 plus P3 plus P5 plus P6 plus P7. Another word, probability less than 8, that equal to 1 minus 0.1471. It's because we know the total sum becomes 1. So now we know the probability at least 8. Therefore, I can calculate from P0 to P7 to subtract this value from the 1. Then the answer becomes 0.8529. Of course, you can just calculate from the P0, P1, P2, P3, I forgot P4, sorry. P4 and P5, P6 and P7. You combine all this probability, still you get the same answer. Somehow I keep on forgetting 4 here, so I'm going to rewrite. But as you see, this is too many different cases here. Maybe it takes about 20 or 30 minutes to figure out all this probability. Instead doing so, because we know so I forgot here. I think I don't like number 4 maybe. So instead doing all these probability value, we just subtract that value from the 1. Then we can get the answer a little bit easier and shorter basically. Okay? So that will be this example answer. Okay, maybe let's do one last question, then I want to end this live lessons. So this question here is, so 28% of college students say they use credit card because of the reward program. You randomly select 10 college students and ask each to name the reason that use credit card here. So find the probability that the number of college students who say they use credit cards because of the reward program is exactly 2, more than 2, and at most 2 here. Okay. So same way, so we know 28% of college students say they are using credit card. Okay. So P equal to 0.28, which means they're using the credit card. Okay, then out of 100%, how much percent didn't use credit card? Yes, 0.72, right? Because 28% they use the credit card, then 0.72 not using the credit card. So we found P and Q value here. Okay. Then now we need to find out how many people we select. So you randomly select 10 people. So N value going to be 10 people again. Okay. So we found N, P, Q. So we're ready to solve this problem. So first question is, exactly 2 people say they're using the credit card. So now you have some sense how to set it up. So P2 equal to 10, C2, and then 0.28, which is I'm using the credit card. So how many people? Yes, 2 people say yes. So 2 multiply 0.72 to the, and 8 people say I'm not using it. So it should be 10C2, 0.28 to the second power, and 0.72 to the 8th power. Okay, so let's calculate that. So 10C2 times 0.28 to the second power times 0.72 to the 8th power. Then the answer becomes 0.25479. So I can round 0.2548. So that's the A answer. Exactly 2 people say yes. Now B. So more than 2 people. So more than 2 people. Probability more than 2 people say yes. So as you see this case, 3 people say yes, 4 people, 5 people, 6 people, 7 people, 8, 9 or 10 people. So like this, we have to find out so many different cases. So instead of finding these cases, because we know the sum of all these cases, equal to 1. So instead of finding from 3 to 10, I'm gonna find out P0, P1, P2 instead and subtract that from the 1. So now let's find out P0, which is 10 C 0, 0.28 to the 0 power and 0.72 to the 10 power, and P1 is 10C1, 0.28 to the single power and 0.72 to the 9th power, and P2 10C2, 0.28 to the square power, 0.7 to the 8th power. We know this one's answer already, which is 0.2548. Okay, so in this case we just find out P0 and P1 value and you combine them, then we will get the answer. Okay. So 10 C0, 0.28 to the 0 power 0.72 to the 10th power. Then this one you will get 0.0374. Then P1 1 times 0.28 to the 1 power, 0.72 to the 9th power. Then you will get 0.1456. Okay, so if we found P0, P1 and P2 value, and now you combine them. Okay, you combine them, then 0.0374 plus 0.1456 plus 0.2548, then you will get 0.4378. okay, which means I'm going to go up again. So this probability value represent 0.4378. That's what we found here. Okay, and now instead of finding P from P3 to P10 and then combine it, instead we subtract this value from the 1, then you can find this answer. Therefore, so probability more than 2 will be 1 minus 0.4378. Okay. Then this answer becomes 0.5622. Okay. There will be answer for B. Now C. C answer is probability at most 2. So we actually found it already. So this means P0 and P1 and P2, which we found, which is 0.4378. So this answer becomes 0.4378. That will be the answer for these questions. So once again, sorry for the technical issue. So I also lost some file, that's why I have to copy and paste from my Word file again. So it looks a little bit not good. But anyway, thanks for joining this live session. And we also make another announcement if we will on another live session soon. So please check out. And then if you subscribe this channel, then you always get notified whenever we have a live lesson. So please check this out too. Alright then, thank you very much, and then see you next time.